Consider the system of linear equations shown here, where u, v, and w are the variables. First of all, this system can be written as an equation involving tuples. So we can write this as the tuple consisting of the two components u minus 2v plus w and minus u minus 2w equals 4, 5. Since equality on two tuples is applied component-wise, this equation here says precisely what this system says. We are now going to look at a new way of expressing this system as a matrix equation. There are three items in the representation of this system of linear equations as a matrix equation. Starting from the left, the first item is called the coefficient matrix. The first row of numbers come from the coefficients of the first equation, and the second row of numbers come from the coefficients in the second equation. The order in which the coefficients appear is important, and that order is given by the variables listed in this second item here. So this second item is a tuple of the variables, and the first entry is u, and that means in the first column we have coefficients of u. And the second entry in this tuple is v, so in the second column we have the coefficients of v. And similarly, the third entry in this tuple is w, so we have the coefficients of w in the third column. As you can see, the coefficients of v is minus 2 in the first equation, so I have a minus 2 here. And in the second equation, the coefficient of v is 0, so I have a 0 here. And the final item is the right-hand side tuple, and you simply take the values on the right-hand side and form a tuple. We could have written this system in a different way if we reorder the variables. For example, we could have written this instead. Notice that the coefficient matrix looks different. We have reordered the variables, so the first column actually corresponds to the coefficients of w. If you look at the coefficients of w up here, they are 1 in the first row and minus 2 in the second row. We have exactly the same numbers here in the first column. And now the second column corresponds to the coefficients of u, which you can see are the same as before. If we let A denote the coefficient matrix, X be the tuple u, v, w, and B be the tuple 4, 5, then the system can be written simply as AX equal to B. And this is a compact way of expressing the system we have up here. Let's now look at this more compact way of writing systems of linear equations more generally. Say we have a field F, M and N are positive integers. A is a matrix with m rows and n columns with entries from F. B is an m tuple with entries from F. And X is an n tuple of x1 up to xn. We define AX to be the m tuple that looks like this. As you see, each entry is a gigantic sum. So this is the second entry of the m tuple. Now here, Aij denotes the ij entry of A, the entry in row I and column j of A. So with this defined, then AX equals B represents the following system of linear equations. And this is a system with m equations and n unknowns.